backend, right? So basically doing things with a Spring. But eventually, I have to go to the front end and do some stuff, and that's why I'm here, right? So how many of you are backenders here? All right, so I guess that's why you're in a Java conference. And how many of you need to do some front end eventually? All right, great. So we are on the same page. So basically, how many Spring users do we have here? Wow, quite a lot, right? So we basically been following all the new Spring releases. There have been a lot of efforts going to Reactive, not only in the core, but also like in Spring Boot, leveraging the project Reactor, and also in all the portfolio, like in Spring Security, Spring Data, Spring Cloud, Spring Integration. So that's basically what we have in the backend, right? So we have a lot of APIs which are already embracing, right, reactive APIs. But today we're going to focus on the front end, right? So we're going to talk about RxJS, which is basically the Reactive X extensions flavor, right, for JavaScript. So this is not an Angular talk, but we're going to see that RxJS is integrated into the framework, and most of the APIs in Angular will be using RxJS. But before using Angular, we need to understand a little bit about RxJS, observables, the operators, how to combine those observables, and maybe dealing with some errors. So we'll start with the reactive extensions. So if I quote the definition from the website, this is an API for asynchronous programming with observable streams. And I want to focus on two words here, asynchronous and streams. So basically, we're going to do asynchronous processing for events that are going to flow into our system. And ReactiveX comes into multiple flavors. So we have support for different languages. If you're using Java, maybe you're familiar with RxJava, and we have actually support for many of them. So we're going to focus today on JavaScript, and RxJS is the JavaScript flavor of the reactive extensions. So if you're familiar with any other reactive APIs, I guess that you'll be familiar with the concepts, right? So you're going to see some familiar APIs and concepts. So let's take a look at the front end. What do we have in the front end in terms of asynchronous events? We have a lot of asynchronous events. We have, for instance, DOM events. So what happens when we update something in the DOM? What happens when we move our mouse? What happens when we do some interaction with our DOM? So these are basically events that will be triggered, right, asynchronously. And we can process those events asynchronously. What about AJAX requests? So AJAX can be also an asynchronous event. So basically we do an AJAX request and we provide a callback usually to get the response back. WebSockets as well, so we usually process those asynchronously. So we start a long-living connection and then we set some kind of callbacks to process the events coming from the server side, and the same applies to the server-side events, right? So we're going to get some events from the server side, and we're going to process them asynchronously. And animations can also be another type of events. So the thing is that we have been dealing with these asynchronous events for a long time. So initially we ended up using callbacks, and then, well, we find out that maybe this was not the best way to handle those events, because we ended up having this callback hell, so nesting, right, events or callbacks and callbacks and callbacks. Then we had the promises, right, which kind of solved this problem, but they were not ideal. We had a lot of open questions still. So how do we cancel a promise, right? Or how do we retry a promise, right? Or how do we wrap a WebSocket into a promise? So we had actually a lot of open questions. So the reactive programming has a lot of pros, but we also have some cons, right? So we're going to move from an iterative programming model into a more declarative programming model. So basically, we're going to define or focus on the result and not on how to achieve the process, right? So we're not going to define when this happens, then, well, do this thing and so on. So we're going to basically define what we want and not how we want it. All right. So a good thing about the reactive extensions is that well, we have a lot of operators that can do a lot of complex things for you, so you don't have to spend time programming things that can be done with one-liners in RxJS. And also, as we're going to use observables, those observables can be cancelled as well, which we couldn't do with promises. So we take for example, an HTTP request. An HTTP request can be cancelled. So we wrap that into an observable. If you're not interested in the HTTP request anymore, you can cancel the HTTP request. And that's usually the case when you have these autofill text inputs or autocomplete text inputs, where for every single word that the user types, we need to go to maybe a service and do the autocompletion. So we might be interested in canceling all these requests. But as said, we have to change it slightly the way we think. We have to think more into more a reactive way. So this kind of programming will be a little bit harder to maybe debug or trace, right? And we have also a learning curve, right, which we didn't have, right, in the imperative way. So how do we get started, right? So we'll be using observables. So an observable is nothing more than something that we can observe. So usually it's the producer of some values. And RxJS has some factory methods to create observables. So we have, for instance, the of factory method, which creates an observable out of some data like strings or maybe basically a static data. We can create an observable from an array, for instance, which is also static. But we could also create observables from events. So what about mouse move events or things that are not static but dynamic? Or we could even create observables from an interval, right? So we can define like an interval and basically trigger events, right, based on that interval. So these are just some of the examples of creating an observable. So the good thing about RxJS is that we're going to treat different data sources in the same way. So we don't care whether this is coming from a static data source or a dynamic data source, coming from a WebSocket, coming from, I don't know, the DOM. So we don't care. We just basically want to get values out of this data source. So how we process these values is going to be completely decoupled from the source. Right? So that's a good thing. So we'll be importing all of these factory methods from RxJS. Right? So you'll have these imports, and then you'll basically create the observables. So usually observables don't do anything until you subscribe to it. So we're going to see that in a second. If you want to have, or if you need a more complex creation of an observable, you can use the create method. So the create method will give you, right, basically the power to define how you want to emit events, right, into that observable. So that's basically giving all the power to you to define how those values are going to be created, emitted, so some other subscriber can receive those events. So at the end of the day, an observer is basically someone who subscribes into the observable. Right? So we need an observer. So if there's no observer, right, there's no need to do anything because there's no one observing. So it's like when you go to YouTube, right, and you want to subscribe into one of these channels. So basically, you as an observer will subscribe to the observable. Right? So in our case, the observable will be the YouTube channel. So we subscribe into it, and when we are subscribed, we're going to receive like values when maybe new videos come out. But if we don't subscribe, then we don't receive anything. So there needs to be a subscription going on. So what's an observer? An observer is nothing more than a set of callbacks that allow you to get, right, the values from the observer. So at the end of the day, when an observer emits a value, it will call the next callback from the observer. So you're getting to you're going to get the values asynchronously, and that's nothing more than a callback. So you have a callback for the next events or next values. You have a callback also when you get an error, and you have a callback when the observable completes. Right? So an observable is usually an unbound set of events, so we don't know when it's going to finish, but eventually the observable might complete. Right? So maybe there are no more values to be streamed, so we're going to receive a notification on the callback called complete. So here's an example of an observer. So notice that we implement the three callbacks, the next, the error, and complete. You don't have to implement all of them. So usually we just implement the next callback, but this is like a complete observer. So defining callbacks for every single situation. So next values, errors, and when the observable is completed. So we kind of separate who is the producer of the event, right? So by using one of these factory methods maybe. So here we see that we use a factory method called interval. So we want to stream values at every single second from who is consuming these values. So remember that in order to consume values, we need to subscribe to the observable. So if we don't subscribe to the observable, there won't be any value emitted. And this subscribe actually gives you the chance to pass the callback that we have seen. So basically we'll define here, or actually what we define here is the next callback. So when there's a next event, we're going to have this callback executed. But the real power, right, of RxJS is the way to define operators in between the producer and the consumer. So when the producer emits a value, we'll be able to transform those values, right, or even basically change the observable, right, or do anything you want before reaching or delegating to the consumer. So we're going to take a look at these operators in a second. It's also important to unsubscribe when you don't need the observable anymore. So when you subscribe to one of these observable, at the end of the day, you're allocating some resources. So it's like when you add an event listener in plain JavaScript, you might be getting some or allocating some resources, and you need to remove those event listeners when you don't need them. So the same happens here. So when we have an observable and we subscribe to the observable, we are allocating some resources. So in order to prevent memory leaks, you should always unsubscribe from those resources. So in this example here, we are creating an observable from the event mouse move. So every time that we move the mouse, we're going to have a value streamed, right, from that observable. And we are subscribing to that observable, and we are basically printing it in the console. So that's basically the subscription. So when we subscribe into the observable, we're going to get a subscription back that we can use it to unsubscribe at some point when we are not interested in those values anymore. So set will be decoupling the producer from the consumer, and we've seen that the factory methods allows us also to decouple the different data sources. So we don't care whether this value came from a static source or whether these values came from a dynamic source. So we're going to treat all the values in the same way. So we're going to stream those values, right, and eventually an observer will process those values, but we don't know where they come from. But in between the producer and the consumer, we have seen that we can add or use some operators. So well, we've seen the creation operators, but we also have transformation operators. I guess that you might be familiar with some of them, like map and scan and so on. Filtering as well, so filter, take, combination, conditional, utility, error handling, multicast. Actually, we have plenty of operators, and when you take a look at the operators, it might be overwhelming. So there are so many operators that you cannot learn them all. So the recommendation here is to start with the basic ones, so map, filter, right? So the ones that are easy, get the job done, right? And as you need more power, then you start learning new operators, right? So, but you don't have to learn them all at once. It might be really overwhelming, and some of them look really similar, but they have like a small difference, right, in between. So how can we combine, or how can we use these operators? So before in RxJS 5, we used the dot notation to chain those operators. In RxJS 5.5 and 6, so which is what we have now, we have what's called the pipeable operators. So pipeable operator is basically an operator that you can use inside the pipe method. So we're going to have the producer, in our case, this interval observable, and then we're going to call pipe, and then we're going to add as many operators as we want. So in this case, we are filtering, and then mapping, and then just taking 5 values, and then we subscribe to that observable. So how can we learn about these operators? If you go to the ReactiveX website, and if you're not sure which operator to use, you can go there, and the site will ask you some questions, and depending on your answer, it will recommend you, right, one operator or another. Right? So basically, you can delegate, right, which is the best operator to use to this kind of form or questions. So it's going to guide you a little bit on the possible operators you can use for your use case. Another good resource to learn about RxJS is the RxJS Marbles, and this is a good way to graphically see how an operator works. So you'll be defining like different observables, and the operator will basically kick in, and you'll see the end result of applying an operator into one of these observables. So this is actually a good resource because you see it graphically, right, and this helps quite a lot. Another good resource is learnrxjs.io. So this has a lot of examples on how to use these operators. So you can have like samples in JavaScript that you can run, and you can see the end result as well. So you don't have to use them all, and you don't even have to use RxJS for everything you have in your application, right? So it's completely fine to go for the traditional way for simple things like, I don't know, I click a button, or I do simple things that don't require RxJS, right? So just use RxJS when you need it, right? So when you have to combine multiple events, when you have to do some async processing, and so on. So another really powerful thing is the ability to combine multiple observables. So I'll try to put all these examples together at the end of the talk, showing you a demo, but now we'll basically see how to combine like multiple observables with different operators. So the first operator that we'll see is the merge operator. And as the name says, this will merge different observables. So let's imagine that we have a couple of observables, and they are creating observables from static sources, so basically from some strings. So the first observable is creating an observable out of these strings, Spring Boot, Spring Data, and the second one is creating the observable from these strings, Cloud Native, Cloud Foundry, and Bosch. So notice the naming convention. When you have this $sign in the variable name, that is basically an observable. So that's a naming convention, right? So we know that this variable is actually an observable. So we can use the merge operator to merge both observables. So we take this observable and this other observable. So at the end of the day, we're going to have like an AND operator here, right? Or operator this and this. And notice how we merge these two observables. This will create a new observable, and then we can subscribe to this new observable, which merges these two other observables. So this simplifies quite a lot the subscription logic. So now, instead of subscribing to two different observables, we just have to subscribe to one observable. And also, we just have to unsubscribe from one observable instead of two, which is quite convenient. So we take a look at the end result. So let's imagine that the first observable emits a value, which is a Spring. The second value is also emitted, Spring Boot. The second observable emits the first value, which is Cloud Native. So we're going to get this in our subscription, and then we have Spring Data, Cloud Foundry, and Bosch. So notice that we don't maintain the ordering of the initial observables, right? Because, well, we are merging them, so as they are streamed, we're going to stream them down into the observer, right? So we're basically merging all the values coming from either one or the other observable. All right, so merge, really simple operator to combine two observables. So let's talk about switch map. So switch map basically takes values from the initial observable, and as the name says, it switches the observable to another observable. So in this example, what we see is that we create an observable of 1 to 3. So when these values are emitted, like 1, we're going to switch map those values into another observable, which will emit 2 values. So the first one, the same value, and the second value will be what we get multiplied by itself. And then we just subscribe to the resulting observable. So we take a look at the end result. So this first line is basically the initial observable. So this is 1, 2, 3. So when 1 is emitted, it will go through the switch map, and the switch map will create another observable. And as we have seen in the definition, it will emit the same value, 1, and then it's going to emit a second value, which will multiply 1 by 1, which is 1. So the second value will be emitted. So we're going to switch map to the other observable and get 2, and then 2 by 2, which is 4. And then we have the last value that came into the picture. And this will basically emit 3, and 3 by 3, which is 9. So we see here that given values from one observable, we can completely change, right, or switch into another observable. Now we're going to see why this is really important. This is a really useful operator to basically change the observable you want to subscribe to. ForkJoin, another way to merge different observables, and this is quite interesting when you have like parallel requests. So let's imagine that you need to basically consume multiple services, and you want to do it in parallel. You don't want to basically do this thing of do this request, then wait, and then do the other request, and then wait and do the other request, but you want to do them in parallel and then wait until all of them have completed. So ForkJoin is a good operator to use in these cases. So we see here an example of using the ForkJoin to fork the different requests, like finding user 1, finding user 2, and finding user 3. So what we'll do is to take in all these 3 observables, and then we'll wait until all of them have completed. So we're going to wait and join all of them. So maybe the first one completes first, maybe then we have the third one that completes, and then we have the second one that completes. So we're gonna wait until all of them have completed, and then the end result will be an array of the values that are the resulting values from these observables. So we're gonna have everything at one time. But we've been living on the happy case scenario, right? And not always we have the happy case scenario. We have to take into account that errors will occur, right? So when you do an HTTP request, maybe we have an error, maybe you don't have network, maybe there's something wrong, right? So we need to process errors that might be thrown when we process those observables. So in this example here, we have a method called range. So we are going to create something in between 1 and 20. And then we are piping it into a map operator. And this map is basically checking whether it's number 13. So if we get the number 13, we throw an error. Otherwise, we return the same number. So basically, we don't like number 13. So the end result of this will be basically getting the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But when we get 13, we're going to get an error. And when we get an error within an observable, the observable is cancelled. That means that we're not going to get 14, 15, 16, and so on. So basically, it gets cancelled. So if you don't handle the error, so the observable gets cancelled, and you don't get any more values. But if you remember, the observer had another callback, which was the error callback. So usually we implement the next callback. So the next callback is giving you the events streamed by the observable, but the error callback is basically getting any error that have occurred during this observable. So now, if we add the callback, so this is basically what we have down there, apart from the next callback. When we have 13, we're going to delegate to that callback. So now we're going to have 1, 2, 3, 4, 5, 6, 7 until 13. So when we get 13, as we see here, we're going to go to the map will throw an error, and the observable is cancelled, and we're going to have the error callback execute it. So what if we want to do something before reaching the callback? We have another operator called catch error. Right? So catch error is basically giving you the chance to replace that error with another observable. So usually we use the catch error really close to where we expect the error. So we're expecting the error in the map, so right away we're going to have the catch error. So the catch error will be triggered when we have the number 13, and notice how we are changing the observable at this point. So we're going to have the output of 1, 2, 3, 4, 5, 6, and until 12, but because when we reach 13, we're going to have this catch error kicking in, and it will create another observable, which is starting at 100, and it will emit 3 values. So that will emit 100, 101, and 102. So that's basically the output that we're going to get. All right, so these are some of the operators that we have in RxJS. So we take a look at the Angular API. So Angular is leveraging RxJS in most of the APIs. So you're going to see observables everywhere. So you can take those observables and basically use any of these operators to modify or interact with the values in the observables. And we're going to find observables in the HTTP client, for instance. When we do an HTTP request, you're going to get an observable back. So reactive forms as well. The router, if you want to do component communication, you can use a subject, for instance, for the communication. So let's take a look at how these observables work. So how many of you use Angular here? Some of you. So Angular has a component-based model. So we define components. And we have some initialization and destruction callbacks, right? And the initialization callback is a good place to define maybe your observable, right? So remember that defining an observable doesn't do anything. So it's basically waiting for someone to subscribe into the observable. So here we have a really simple component. We have the ng-on-init callback implemented, where we define an observable from the event's mouse move. So when we move the mouse, we're going to map that or those values into basically an x and y value. Right? So we are not interested in all the event, but only in x and y. So that's basically our definition. But as said, this is not going to do anything until we subscribe. And we know that we have the subscription or the subscribe method. So we'll basically subscribe to the mouse down observable, and this will give us back a subscription. So remember that we can use this subscription to unsubscribe from the observable. And a good place to unsubscribe to from the observable is the onDestroy callback. So basically, when a component is created, we're going to create the observable, and when it's destroyed, we're going to unsubscribe from the subscription or the observable. So it's really important, right, to unsubscribe from any single observable that you are not interested in, because otherwise you'll have memory leaks, right, and you don't want to hold resources. But luckily, Angular has something called the async pipe, right? So the async pipe is reducing the subscription logic, right, and basically managing all the subscription for you. So notice that in our onInit method, we are just defining the observable, and we are storing this observable as a private field in our component. So we are storing the mouse position as an observable of strings, and we are not subscribing or unsubscribing from it. That's going to be done in the template. So in Angular, the template is basically what's going to be rendered. So we're going to use the mouse position observable and use the async pipe to say, well, you have to subscribe to this observable and output the value from this observable. And when you're done, you're going to unsubscribe from the observable. So we don't want to manage the subscriptions explicitly because it's error prone, right? And you should have as many you don't want to have a lot of subscriptions, right, in your components. So as long as you can, just let Angular do that for us. So we take a look at the HTTP client. The HTTP client has all these convenient methods to get, post, put, delete, and all of them will return an observable. Right? So that's basically, or maybe, the first place where you'll encounter the observables. And well, It's basically a really simple API. You can actually define the type of the result of these calls. It also supports interceptors. So here's the definition of the get operator. So notice that you can parameterize it, and you can pass things like the headers and parameters and many other things, right? But if you take a look at the return value, it's an observable of t. So when we call the HTTP client.get, we parameterize it. So maybe we are interested in a user, we define the URI or URL, and then we have to subscribe to it. Because remember that if we don't subscribe, there won't be anything happening. So if you just call http.get, nothing will happen. There won't be any request until we subscribe to this observable. So we basically subscribe and we pass the next callback. So a really nice thing that we can do with RxJS is to retry the operation. So sometimes, as said, there are some errors that can happen. So we can take the observable that comes from the HTTP client and pipe it into the retry operator. So we are going to retry 3 times before failing, because maybe there's a network glitch, so there's something that doesn't work at that point, but maybe if we retry, we're gonna go through. If you need a little bit more power on defining how to do the retry, you can use the retry when operator. So retry when operator allows you to define the logic on when you want to retry. And in this example, we are taking the errors, and we're going to delay the retry for a second until we have 3 attempts. So we're going to reattempt 3 times, or try to call that URL 3 times. Another place where we're going to have observables is in the reactive forms. So Angular has different ways to deal with forms. We have more template-driven forms and the reactive forms. If you choose to go for the reactive forms, you're going to get different methods that will give you when we change values on an input text, for instance, or when the status of an input text has changed from valid to invalid. So it's basically a good way to receive a stream of events which are going to be the what the user types into the text, for instance, or the status of the form control. So if you use WebSockets or server-sent events, it's really easy to wrap those into an observable as well. So we have seen that we have the create method. So you can create an observable out of an event source. Right? So an event source is nothing more than server-sent events. Server-sent events are basically, or it's a form of HTTP streaming where you define a long-living connection, and you're going to get like values emitted from the server side. So here we see how we create an observable out of an event source, and we basically add an event listener and say, when we get a new value from this event source, we're going to call next. So basically we're going to push a value into the observable. So anyone who is subscribing into this observable will be getting this new value. And the same applies to a WebSocket connection. So we can wrap a WebSocket connection into an observable. So this is basically the plain WebSocket JavaScript API. So we're going to create a long-living connection where you can send and receive messages from the server side or send to the server side. And every time that we get a message, we're going to call observer.next. So basically, who is subscribed, we'll get the value. But we have a problem here. So when we call subscribe into these observables, a WebSocket connection is created. Right? So that means that if we have different components that want to get a WebSocket connection, when we call WebSocket.subscribe, this is going to start or create a new WebSocket connection. And this will happen every time we subscribe to this observable. Right? So in a single page application, usually that's not what we want. We want to have a single WebSocket connection, and we want to share that WebSocket connection across the different components. So it's enough to have one WebSocket connection. So if you want to share the subscription, what you can do is to basically use the share operator. Right? So you can take the observable and say, well, I want to share this observable. So every time that there's a new subscription coming in, there won't be a new WebSocket created, but we're going to share the observable. And then this observable will be there until the last subscriber unsubscribes. So it's going to hold until everyone has been unsubscribed from the observable. All right, so with this thing, I just have a demo, really simple demo. And this is basically an Angular application, and the main purpose of this Angular application is to basically get data from GitHub. So you have the components here. I have this component here, which is the user component. So it's basically fetching the user from GitHub. And then I have another component here, which is not shown yet, which shows the repositories from this user. So the main intention of this demo is to be able to search on GitHub. So every time I type something here, I want to see the user, which is basically on GitHub given this name. So let's take a look at the component. So this is basically my component. So what I have defined, let me just go to the service first. What I have here is a service called GitHub service. Can you see the code from the back? Is it okay? Yeah? Okay, so I have a GitHub service, and it basically contains a couple of methods using the HTTP client. So I have a method to get the user by the name. So it basically uses the HTTP client to get a user, which is a type I have here defined. So this is basically my type, a user, and I also have a repo. And it's basically interacting with GitHub to get the user and get also the repos. Notice that these methods return an observable, which is what's returned by the HTTP client. Right? So basically, we take what's returned from the HTTP client and send it back. All right. So in my component, I'm going to use these services to get the data from GitHub. So first of all, so if we take a look at this piece of code here, I'm going to use the service to find by username. So this will give me an observable, but notice how I use the pipe operator to catch the error. Because if there's an error, let's say a 404, I don't want the observable to be terminated, so I want to map it into an empty user. Right? So I want to basically have an empty user instead of an error. And I'm going to store that into a private field. So this is the field defining the observable, and it has composed this catch error operator. Notice that there's no subscription here yet. So that means that this definition won't do anything. So it won't go to GitHub until we subscribe to this definition. In the same fashion, we have this repo search. So repo search is also using the service that we have seen to go to GitHub and get the repositories by a specific username. And what I've done here is to use the map operator. So I'm going to use the pipe method and use the map operator to filter out some of the repos that come from the user. So in our case, we are only interested in the popular repos. So we are only interested in the repos that have more than 50 stars. Right? So that's what we do here. We map it we take the repos, we filter them, and we only leave the ones that have more than 50 stars. All right, so now what I'm doing here is to basically create a static observable. So this observable is basically based on a single string. And we're going to pipe it into a switch map. So what we're going to do is to take this string, and we're going to convert this observable into, or pass it into the user search observable. So the user search observable is actually this one here, the one that goes to GitHub, tries to get the user. And notice how we then subscribe to it. So that will trigger the actual subscription, or actually the actual request. And whenever this request is done, we're going to assign the user, right, or the result into the user, which is a private field, which is what I'm showing into the website. So we refresh this. So that's where we are now. And we go to the network. Network. We'll see that there's actually one request, which is this one here, right? Which is the one going to GitHub. And this is the one triggered by the subscription that we have seen. So what we want now is to, apart from getting the user data, we want to get the repos. And we have seen that we have an observable that will give us the repos of the user. So we can use the ForkJoin method to combine these two observables into one, for instance. All right, so we can actually create another observable. We can call it user and repo search, and we're going to basically username and map it to the ForkJoin. And I'm going to just put it down here. I'm going to join two observables like the user search, and also I'm going to merge the repo search. Right, so I'm going to do these two requests in parallel. Right, and that's basically my new observable. Right? All right, so now I can take this observable and switch map to this observable. So this will ForkJoin, so this will do the two requests in parallel, wait until we get the result back, and then send it to the downstream. So if we go back to so I've done something wrong here, maybe. Yep, I'm missing this maybe. ForkJoin, username. Of course, this is demo, so we have the demo effect, right? So I'm going to just copy it here because I don't want to spend a lot of time with this. So let's see if I've done anything right, wrong. I don't see what. Wait, I know. So basically, when you do a ForkJoin, the thing is that we get an array of results, right? So we're seeing here that subscription basically takes one result because we had only one observable before. So we have to change that, right? So I'm going to change that and say, well, user is the first result that I get, and then the repos, of course, we didn't map the repos, right? It's going to be the second result. So hopefully that will give us something better, and here you go. Right, so we have the popular repos here, right, which is the second request. So we take a look at the network for a second. So we see actually two requests. The first one is getting the user, and the second one is getting the repos. Right, so it's basically doing them in parallel, waiting them, and basically getting the result back. And that's why we had to change a little bit the subscription, because when you do a ForkJoin, you get as a result an array of different observables. That's pretty nice, right? But what I want is to make this dynamic, and I want to be able to type up here some name and display that user. So far we have a really static data source, which is this one here, but I really want to get those values. And when I initialize the component, I have this init form method that initializes that little form, and it creates a field called search field. So as this will use the reactive forms, what I can do is to get an observable from the text, let's call it text search. From these fields, I can just call these, and this is called search field. And I'm interested in getting the values changes. So every time that the values changes, we're going to get a value back. So let's try to get this text search observable, replace it by this static source, and let's see if we can pipe that into the other observable. All right, so SALMAR. So we see that every time we type into the text box, we're going to get a request. So let's say S. And so we see here how we have a request to GitHub for the user S and the repos as well. And you can actually combine that with WebSockets, for instance, server-send events. I think that we are out of time already, but maybe we have some time for some questions. Do we have one question? Do you have any question on this?
Let's say in your field, you type like slowly, type like super fast.
Yeah.
You get almost wrong over.
Yep. So the thing is that usually when you type real fast, you're not interested in the responses from previous requests, right? So that's why as an observable can be canceled, right? So you want to cancel all these previous requests, and this can be done easily, right? So you're not interested in those requests anymore. You'll be canceling those requests and taking only the last one. Right? So we have some operators like debounce, which basically allows you to wait until the values have changed. Right? So let's say if I type really fast, I'm not interested in all the values. I want to basically take the last value, let's say when the user hasn't typed for half a second or 1 second. Right? So I want to wait until the user has stopped to issue the request. Right? Then this is usually what we do. All right, so time's up. So thanks for coming.